Usually G has the notes up and ready to go. Do you see the notes? Okay. He will do that. You can see it by the, it is good to see you. Might as well start. Let it go. Straight in front of me. Okay, folks. I need help because I'm not, I'm soft-spoken anyway. If you can't hear me here or online, if you would let me know. There'll be several presentations. Can you all see the chair slides? Good. Jeff is going to go to the next slide. Okay, this is the note well. If you need a moment to read the microprint, raise your hands. If not, read it online. It's got a lot of good things about IPR. It's got a lot of good things about behavior. Any questions on the note well? Okay. I'm trying to be short today because we have just this one session. Location, location, location. This is location of all the various places. If something's not there, drop a note online to the chat. G was our wonderful working group secretary, and he will help you. Bashing agenda, if you have a problem with the agenda, let us know now. If not, we're going on to document status. It's on the wiki. As I said, our loving ADs gave us 2 hours, so we're trying to be brief. I will send out a overall status tomorrow morning. Just in case you were missing mail on IDR. Next. This is our agenda. Is there anyone who wants to make any comments? Please note our, maybe some of you are looking for our car CT discussion. We will have a few presentations before then. And Jeff, if you'll go to the next one, we'll call it done. Any questions? Purpose of this meeting is to get feedback, input. Okay, we're going to pick up with the first presentation. Pardon? It's, oh, I got one more. Oh, I forgot. I have the first one. Okay, guys and ladies and gentlemen, BGP auto configuration. We had too little participation to improve any of the specifications. We spent a lot of time working on it and then sort of fizzled. What happened? We're looking for feedback, privately, publicly, with a wet noodle. Shall we try any of the adoptions again? Shall we send all of these guys, all of the drafts off to the independent stream editor? And Alvaro comes up with a.
Hi, Alvaro Rotana, Routing AD. Just to be clear, it is not an option for us to send anything to the ISC. That is a decision that the draft authors will have to make if they want to still publish the draft. The decision that we could make is, do we try adoption again? Do we just not adopt them? But what happens after the working group is something that we cannot decide.
Yes, we can only not, speaking as a member of the editor board, usually they will query me and say, is the working group let go of this one? And Alvaro is precise and correct. Thank you for the correction, Alvaro. Yep, interims. Thank you. Folks, how many, I don't know if those who are virtual tried to get a time slot at IETF 114. Tentatively, we were thinking we might hold an interim in August on the 29th to let those people talk. If you are one of those people who didn't manage to get a time slot today, if you would please let the chairs know or send a note to G so we can determine if we should schedule this interim. We'll schedule others if we need them by topic, but nothing else is currently even tentatively scheduled. Are there questions? Alvaro, how did I do on this one? Better?
You know, I need to give the credit to John, who whispered in my ear and said, "Go say this." So better? Yeah. So John says, "Yeah, we're doing better." Thank you.
Okay. First question is, I fit Giuseppe? I'm not seeing you. Are you online today?
Yeah, can you hear me?
Yes, we can hear you.
Hopefully,
Please go
you
ahead.
can also see me. Hello, everybody. Yeah, this is an update about the BGP extension for advertising IFIT capabilities. The draft has been recently adopted. I'm Giuseppe, and I'm presenting on behalf of the co-authors. So next slide. Yeah, just a few words about the background and motivation. So IFIT stands for In Situ for Information Telemetry, and it's just a name to refer the data plane on path telemetry techniques, including in situ OM defined in the RFC 9197 and alternate marking defined in the RFC 8321 and 8889. And we are currently working to the BIS document to elevate this methodology to proposed standard. Since these are solutions requiring into limited domains, it is required that the ingress node learn the IFIT capabilities supported by the end node in order to avoid data leaking from the domain. So in this way, we need to define a mechanism and an extension to BGP to advertise IFIT capability. In this way, the tail node can advertise this information to the end node that can determine what are the IFIT options that can be encapsulated. The typical scenario is the distributed one. So next slide. So the BGP next hop capability attribute is defined in another document. It is the next hop capability draft. This next hop capability is a non-transitive BGP attribute, and the important characteristic is that it is updated or deleted when the next hop is changed. This is an important characteristic because it guarantees for the limited domain application that when the next hop change, also the capability reflect the next hop. The document define these new IFIT capabilities that can be encoded as a next hop attribute. It is defined in 16-bit bitmap. So 5 bits have been defined. 4 are for the IOM option type flags, and 1 is for alternate marking flags. When a specific flag is set, this indicates that the router can process the specific method. Next slide. This is just an example to how it works for IFIT domain application. So when a BGP speaker sends an update with the BGP next hop capability attribute, it may include the IFIT capability. This allows to advertise the supported capabilities, and in this way, the IFIT encapsulating node is aware if the decapsulating node can process the specific IFIT option. In case of multiple domain, they can still build, let's say, a controlled domain. And in this case, the router reflector may also pass this information between different clusters to keep the IFIT methods consistent between different domains. Next slide. Yeah, just a few words about the ongoing discussion. So during the adoption, there were several comments that were already addressed in the latest version. In particular, I want to highlight that it has been clarified that the only solution in scope is the next hop capability attribute, since it is a non-transitive attribute, while all the additional extended community is no longer considered in the current version. So it may be discussed for one of the next version or for a separate document, but it is out of scope for now. Also, I want to thank you for open discussion with the IPPM working group. So we received also some feedback from the IPPM working group, and this feedback will be addressed in the next version. In particular, a clarification about the use of the term IFIT, and most important, the relationship with draft in IPPM about the IOM conf state. So it is a similar mechanism, but it uses ICMPD6. So we have to distinguish the scenario when BGP is the best option and other cases where ICMPD6 can be used. Next slide. I think is the last one. So yeah, welcome question, comments, and thank you. I see that I'm a little bit out of time. So.
Thank you, Giuseppe.
Okay, thank you.
All right, this is Mahesh Jaitanandani. I'm here to present a status on the BGP Yang model. Next slide, please. All right, the status with the -14 version of the draft. A lot of cleanup on the draft, mainly to move the stats for total paths and prefixes into its own container, the stats container. And more importantly, clean up the use of counters and consistency in its use across the entire draft. We had multiple definitions we were using, so clean that up. Canonize the order of all the features. But most importantly, probably in the draft itself was securing the BGP session. So we had put forth a proposal, but after looking at it a second time, we decided that we needed to make changes to the TCP Yang model, and the changes for which were proposed in TCP. By the way, that model is an ISG discussion right now. And essentially that augments the keychain model and provides the ability for BGP to just make a call to say that it wants to secure the particular session or not. The other was a redundant MD5 auth password that was just sitting around, we had not removed before. And the corresponding example for how to authenticate a BGP session has been updated in the appendix. The other major change, that BGP types module now is an IANA module. Mainly, we moved it to provide the ability to update it easier with an IANA module. The other big change in the BGP module is the addition of RAW to support new and experimental extended communities. And that's by use of this particular type string that I show on the screen. So essentially a pattern that is raw : followed by up to 8 octets. Any questions? If not, I'll still take them at the end. Next slide, please. As far as issues are concerned, we're tracking them on that GitHub link that I show up there. As you see from the previous version, we have knocked off the major issues related to extended communities. We are now down to issues related to policy configuration, and we need to do that cleanup in the next phase. Next slide. So as I said, next steps are, we believe that the policy configuration is the last major issue we need to address. The rest of the cleanup is mostly editorial that we need to take care of. And then we hope that we have the draft ready for publication by IETF on 15. Thank you. Any questions? Nope.
Next presentation is the end.
Ian?
Hi, my name is Gian Mishra. I'm with Verizon, and I will be presenting this draft uh, I mean, on behalf of co-authors. So the draft is connecting IPv4 islands over an IPv6 core, 4PE. Next slide. So the motivation for this draft is, so an IETF standard exists for connecting IPv6 islands over an IPv4 core. Everyone's pretty familiar with that, RFC 4798. However, standard does not exist for connecting IPv4 islands over an IPv6 core. So this draft provides a specification for connecting IPv4 islands over an IPv6 core. As operators migrate to a single protocol IPv6 only core, per RFC 5565, software mesh framework involves, 6-to-4 tunneling of 6 packets over a 4-core called 6PE. Now with this draft, a similar 4-to-6 tunnel of IPv4 packets over an IPv6 core can now be instantiated, now called 4PE. The name 6PE was termed that way for tunneling IPv6 labeled packets over IPv4, and now similarly with 4PE, the term defines the tunneling of IPv4 packets over a IPv6 core. Next slide. So the 4PE architecture and overview. So 4PE roughly, 4PE routers exchange IPv4 reachability transparently tunneled over an IPv6 core using multi-protocol BGP RFC 2545, using BGP next hop fields conveying the IPv6 address of the 4PE router so that the dynamically established IPv6 signaled LSP can be utilized without explicit tunnel configuration. So this is basically the signaling the topmost transport label. And then 4P uses RFC 8950 next hop encoding 16 or 32 byte next hop for a IPv6 address / link local address. Ingress and egress PE routers must bind the label to all IPv4 prefixes, BGPLU, RFC 8277. And then 4PE supports explicit null signaling for disk serve pipe mode model, RFC 3270. And then 4P supports RFC 4364 InterAS options A, B, C, and AB, as well as 4P design, as well as supports 3 data planes, supports MPLS, SRMPLS, and SRv6. Next slide. So this is just a graphical depiction. So this is with 6PE. So basically you have really there's 2 main components. One is signaling the transport layer, transport LSP over an MPLS core. And that's shown signaling from the ingress PE to the egress PE, building that LSP. And then BGPLU labeling the IPv6 prefixes, all prefixes that are advertised from the CE to PE, labeling them with 6 on the 6PE router. Propagated, the control plane propagated from ingress to egress. Next slide. So with 4PE similarly and an MPLS core, the ingress PE signals and establishes a transport LSP, an IPv6 LSP across the IPv6 core. And then as well, the service label bottom of stack, BGPLU, all the V4 prefixes have a label binding and advertised across the control plane from ingress PE to egress PE. Next slide. Similarly with SRMPLS, if you have, let's say, a centralized controller where you're building the SRTE path, is instantiating that path to your egress PE, your transport would be built across the core from ingress to egress to your node SID on the egress side, and then your VPNs, your bottom of stack service label with BGPLU, that piece all remains the same. There's no change from MPLS to SRMPLS. Just the transport piece changes. Next slide. With SRv6, RFC 9252, BGP SRv6 services, BGP prefix SID attributes. So here the SRv6 L3 service TLV, BGP label transposition. So this is where the transposition happens to the function / argument field. So that's defined in section 5.3 in that RFC. And then RFC 8986, the R76 programming draft, section 4.7. I'm out of time. No, okay, all right. So basically here the transport labels is built. The controller instantiates the transport path across the core, and then the VPN service, the bottom of stack service labels are basically is exactly the same as the MPLS as well as SRMPLS, the binding BGP LU for the control plane binding of all the V4 prefixes across the core. We can just go to the last slide. Just, yeah, go all the way down to the last slide. So I'd like to solicit the IDR workgroup for feedback and comments on the draft, and thank you very much. Thanks.
Thank you very much, guys. Okay, DJ, will you test your mic before we begin? And Kaliraj and Nats, if you would come to the front. Okay? I'm gonna start talking while you move. Okay, this is a summation. Gotta get, how's the sound? Okay, folks? Okay, thank you very much, Jeff and the rest. The CAR, CT adoption call. Our presentation is from DJ and Kaliraj and Nats. Swadesh may add in. Go ahead, Jeff. So the adoption call went from just after July 6th to July 27th. We had a tremendous amount of people respond, lots of wonderful input, and about last week, I sort of summarized what I'm going to say next, that the chairs were heading toward. The IDR Wiki has summaries and notes. Because it was a lot of input, I wrote up notes. You can find that on the IDR Wiki. Go ahead. One thing that really helped us is we've got a lot of input and detailed input from folks who were customer support people, and we used that to gauge customer, and we had a lot of really off-channel and on-channel input from operators. What we're going toward is maybe not a perfect solution, but we're going to take the two drafts as on the experimental track, and we'll generate as a working group an interoperability document between the two. Why did we go that? The customers we talked to convinced the chairs that the technology is needed in the field. Therefore, the interoperability between CAR and CT seemed to be less important than deploying the code. The working group will need to do substantial work to turn the drafts to RC quality. There is a concern that we need to make sure the error handling is well done and that everything is specified for the environments it's going to go to. Now, the benefit that I've asked the authors to provide is I've asked them to describe some of their deployment use cases. And that's not all the possible ones, but I've asked them to pick up one or two. One question I've had from several people is, how do you go from experimental to proposed? Well, after you revise and get that critical customer feedback, because you've been in the field, we can revise the draft or say perhaps that it's perfect and turn it into proposed. Now, I must suspect that Alvaro and other ISG members would like to see an interoperability between these two drafts. And as always, it is an IDR draft, so it will be two implementations. At this point, we believe we will request two implementations for each draft, but again, we will take this to the working group. Now, for our topics for this conversation, we're going to go through the customer examples, the issues that were raised on part 3 of the adoption call, the CAR next steps, that is what things they'd like you to help them with to refine their draft, the CT, and then I'll briefly tell you where we are with the interoperability document start. So we'll start first with DJ. Go ahead, DJ. You should be seeing your slide in front of you, thanks to Jeff.
Thank you, Sue. Can you hear me okay?
Yes, I can.
Sure, thank you. So I'll do a brief overview of a fairly typical deployment scenario. This is not tied to a specific customer. I mean, we generalized it, and in general, the pattern repeats across many customers that are looking at this solution. So this base use case is for establishing different multiple intent-aware paths to a specific router in the network, most likely a PE, a PE loopback. And the PE loopback is actually the BGP next hop of a service. So obviously the service can be L3 VPN in many cases. Often it is the global table, and then also more recently EVPN. So these are the typical cases that we have from a service point of view. And when it comes to intent, again, there's different types of intent that we are seeing. Like there's obviously low latency. We have avoidance is a popular use case. There's things like diverse paths, etc. So most of these fall into the same pattern that for a PE you can have more than one intent at the same time, where you need color aware paths, and we need to support that across a multi-domain environment where BGP is used. Again, I've shown a single simple topology, but in reality we do see variations, both multi-AS and multi-IGP. And then again, for the purpose of this talk, I, just took the, a common case that we see, in many scenarios where we have IGP Flex Algo being enabled in the, in the respective domains for providing the intra-domain intent. But again, there's variation there. In cases where we have existing networks, we see things like RSVP-TE. In some cases, we even have a need to go over a BGP LU island. So in general, all these cases are covered in the draft. But here I just picked sort of one simple scenario. Next slide, please. Another case which sort of dovetails into the one that we saw earlier is in the multi-domain environment. We very often have the case where not all domains have the same number of colors or intents. That's what we refer to in the BGP card draft as the N:2M mapping. So here we see a very typical example where in the core you can have more colors, so shown 4 in this example, whereas on the axis you have fewer, say 2. But now this is really decoupled from the what's needed end to end between the between say a pair of PEs. So again, as you see in this example, there's 4 colors, C1, C2, C3, and C4 for specific egress P E3. When those routes go across this multi-domain network, they do need to map to the respective one of the available intra-domain intents, and that is handled in BGP CAR by leveraging the same mechanism that we have for service steering today, where the color extended community is used to steer service routes through a particular color aware path, transport path. The same way, when it comes down to this second layer of resolution, a color extended community on the BGP CAR route allows for resolution into a specific intra-domain intent. Again, the details are in the draft. Next slide, please. Now here we have a slightly different case where instead of having a color aware path to a specific router, what we have here is traffic that needs to be sent across one of a set of nodes that offer a kind of anycast service. So here, instead of it being a single PE loopback IP, here we have an anycast IP and a color that goes along with it. That's advertised by a set of nodes, which can be in the same or multiple domains. And in terms of traffic forwarding, from different ingress nodes to, these set of nodes, the base scenario is where you have the network providing an anycast forwarding mechanism where traffic goes to the nearest set of nodes. In this example, we have traffic from E11 landing on the nodes in domain 4, whereas the traffic from E21 being load balanced across the nodes in domain 5 and 6. This is just an illustration. Again, there are variations here. One typical variation is where it is the ingress PE which does the explicit load balancing across the set of available egress domains. One thing to mention is in this sort of case, the expectation is that any of these nodes that receive the traffic are capable of forwarding the actual payload, more likely a sort of a global table, distant traffic. Again, this is just a quick snapshot of a few of the common use cases that we are seeing in the customers that we are interacting with. Thank you very much. Again, details are in the contract.
Hi, I'm Kaliraj.
Closer. Yep, hold it.
Hello. Yep. So we are going to describe the use cases that we are seeing for BGP-CT, and these are a few use cases which can be classified as the well, basically whatever use case we are seeing. We just classified a few types of them, and we have listed the customers in some cases wherever it's possible. So this is the first use case where you see two domains which are using their own intra-domain transport protocols. And these are like existing deployments, which may use like RSVP in both the domains. And some of them may be moving to SRT in some of the domains. So this is a typical deployment scenario that we are seeing, where customers want to offer end-to-end SLA, and the BGP-CT is able to help them with this. So this is an example where one of the domains is moving from RSVP to SRT, but you can also imagine the other customers who are RSVP everywhere and they want to stay like that, and the solution works for that as well. Next slide, please. So this is another example where the flow-based forwarding that using BGP flow spec, if they want to be given a certain SLA, and how does that work? So we just have the service chain element that is being advertised in BGP-CT with a different transport class. And those transport classes, they resolve over the TC100 tunnels that are there in the core. And the BGP flow spec routes, they just carry the redirect to IP next hop with a transport class. So with color, and that allows them to resolve the flow spec route over the certain transport class, which can be RSVP, SRT, or any kind of tunnel again. So this is just a typical flow spec example, which carries the color community, and it's able to put traffic over a certain SLA. Next slide, please. So this is just an example of a customer input on IDR that explains why heterogeneous color mapping is a reality in today's networks, and also non-agreeing color domains are reality in today's network. And any solution needs to cater to both. Next slide, please. So if you think about it, the flow spec example, or this non-agreeing color domain and heterogeneous color example. So the BGP-CT solution, it just has base transport tunnels, which are of a certain color, and it automatically creates the resolution schemes for that color 100 in this example. And whenever you have another color route, like 101, 102 in the flow spec example, or this compound color in 100 to 100 in this example, we will just map it using custom resolution schemes to the transport tunnels that are available, the transport colors that are available in that domain. So the service routes or the other transport routes, they can resolve using custom resolution schemes to the transport tunnel. So this is overall how the whole BGP-CT thing works. I think that was the end of the slides. Yep.
Okay, then it's my turn. There are issues that you will have seen on the third part of the adoption call. We tried to keep the adoption call with requesting information, requesting call for adoption, and then issues with either draft. So you will note on the left-hand side, CAR's issues and CT's issues up to the line are the same. There are various questions that work for it. Below that, the authors have slightly different issues. I'm not going to read through all the issues so that you can ask questions later, but I am going to tell you that's a sort of breakdown. And so the authors are going to tell you which of their issues they'd like help with first. DJ, it's your turn as we turn to the next slide.
Oh, thanks, Sue. So in general, we have gotten a good amount of feedback from various collaborators on and off the list, and that has helped the car document to get to the current version. Again, we would request wider review and feedback on the current version. And at the same time, there are certain areas that we intend to update in the in the next couple of versions. So a couple of key ones being detailing the SRv6 related flows and some considerations, and then updates on the filtering mechanisms to be used for BGP car. So we again request folks to help with that, and also provide additional input on other use case scenarios to make the draft complete. Thank you.
Nats?
Am I audible? Yeah. First of all, thanks for.
Can you hear Nats? Louder.
Sure. First of all, thanks for adopting BGP-CT, and my best wishes to BGP car team as well. So the first things we need help with is to clarify text for disallowing SRv6 transposition for SOFI 76. So this is something that we would do in the next 4 months. And the next one is text clarification for section 8 for usage of RD. There has been some back and forth on part 3 about this. And we've taken an action item to clearly list the flexibility of using the same RD versus unique RD and the different label allocation modes that are available in BGP-CT. So to address all the scenarios that have been pointed out in part 3. Then there is a point about expressing and processing customer intent, which is on the CEP links, so which is analogous to VPN car. So here we have to add text for control plane as well as data plane procedures. Control plane procedures are for mapping, signaling the customer intent from CPE, some PE to CE, and then the data plane procedures to map the customer intent coming from the CE onto the PE. So these, the idea is to actually not use new AFI-SAFI, but handle it within the attributes. And for the use cases that we have projected a little earlier, we have some backup slides to explain those use cases in details. So if you do want to take a look at those use cases, please help yourself. I think that's about it.
Thank you, Nats. Okay, the interoperability document. We're going to look to see if we can find a path to interoperable features. There are big picture questions that we received input on. What's a color for? Color in the LRI, not in the LRI. Impact of packing and translation. Now, this to me is an important piece because the use cases suggest they will be used in some 5G networks. So packing and packing is important both in the LRI and in the attributes. My big desire is to see strong error handling and to have the working group talk about error handling when you have a lot of attributes and a lot of non-key fields in the NLRI. So I expect to continue my uh, warm debates with the authors on air handling. There's places in each draft in CAR and in CT where we want to make sure we tie down filtering and how to talk about different filtering. What I heard from some of the providers is their need for filtering or aggregation in their policies, even in the color situation. The expression of transport intent as inter-AS VPN. You will note we had discussions on type A, type B, and type C. We'll need to talk about this as a working group to sort of set our bar for this upcoming set of work. Now, today a couple authors told me that they had a color draft for SRV6. That's nice, but we need to guide this work in one way. Jeff, would you go to the next slide, please? Thank you. Okay, just to show you some of the challenges, Jeff, I stole this from Jeff because he did a lot of the foundational work for the chairs determining that these are functionally equivalent. I don't think the call has changed our attitude at all, that these are functionally equivalent and operationally different. So take a look. This is eye candy, or study it. This is the CAR NLRI and LCM community. Go ahead to the next. This is the CT NLRI and transport community, extended community. We will need to talk about how interoperability works as a working group. These are now going to become working group documents, and we will work on them. There are implementations in play. So folks, that's the end of our presentation, as it's been an active working group adoption call. Now is the time for questions online or in person. If you would step to one of the two mics and let us know if we can provide you more details.
Kiriti Campella.
Please, go ahead, Kriti.
So you said in the preamble that deployment is more important than interoperability at this point. But you talk about the interoperability document. Is it not important to give a deployment experience after a while to say, is it fit for purpose for whatever people want to do with it? Is it easy to use? Is it easy to work with? And also on the implementation side? Or are we just going to go straight to interoperability?
So let me frame your question, if I may, to make sure I understand it. First, you're asking, should we define what it is supposed to do as well as interoperability? And that's a really good question. Here's the reason we hadn't charged with both feet into that direction, is that Spring is working on something in this area, and there is still at the individual draft, so we're sort of waiting to see. It does have input from both sets of authors. So at that point, once we see another round of the Spring discussion, we'll pick up, do we need a new one? Do we need to refine it? Or do we just reference it? I mean, why redo work in this environment? So that's where we are. We're sort of waiting.
Okay.
Input from the working group is helpful.
Okay. Makes sense. Yeah.
I don't see anybody in the queue. Folks, after all the talking on the mail list, have we run out of steam? Kriti, thank you for asking one of the really good questions. That excellent question. Probably should have put it in my notes, but excellent. Because we need to know where we're going. The adoption calls were like taking a term paper. It's because we need to know where we're going. Any more questions to those in the online scenario? Please do.
So the slides do have a large number of backup items in there. You know, you're strongly encouraged to take a look through the additional content that's going to be available. These are things that the CAR and the CT authors have in some cases previously submitted, but it helps expand the scenarios. And clearly the authors are still on the mailing list paying attention to the various threads. I think that the core 3 question threads have come to conclusion at this point. So please feel free to start completely separate threads. You're absolutely encouraged to ask hard questions technically. You're also required to be respectful as part of those questions and stick to technical observations.
And go ahead and queue up to the mic. And I'm going to make one comment. Thank you for everyone during the last couple weeks when I've said, please move to 4 and 3. In technical questions, we will probably, for this topic, try to have the level of detail that we had in Forum 3. If you have any questions on how to do that, just drop a note to the chairs. We'll be glad to help you. Go ahead, Grady.
Hi, Kiriti Compella. So the interoperability report, is there an implication by having that eventually both will become standards? Or are we even thinking, am I jumping the gun on that? Is one going to become a standard and one going to go away?
So, Creedy, if I had all of those answers, I would have given them. The answer is I'm taking them forward to, I've listened to the customers and they've said what I reported. I believe that these folks will take their thing all the way to experimental. Some questions have been, is there a quick term from experimental to proposed? Probably, because these are fairly well developed works. Yeah. The experimental is because I wasn't, as the chair who is
neutral,
chartered with shepherding this, I couldn't see where we really had enough clear consensus one way or the other. I think if you watch the list in my reports, you'll saw that it isn't clear one way or the other. Yeah. But the customers really said, in each of the cases, I really want that. And we've had dual setups. In fact, you saw a couple of the customers say, please do exactly what I did. I'm going to wait and see. My attitude on many of this is I think the hardest thing is scaling in error-free code in this point. And I think early customer deployments from people who've said they were going to do it will teach us a lot. I hope my goal is always to come out with one single solution. Whether I'm going to get that in this place, we're going to see what the working group says. And that's my best as a Shepherd chair. Anything else, guys?
So, Kriti, partially to your point, we have more than one place in IETF where more than one technology has come out covering a given space. We have examples in multicast, we have examples in L2, as you're aware of. And what we're probably looking at, is what interop probably means in the short term is how do you make these technologies interact together in the same network so customers can solve their problems when one solution may be appropriate and the other solution is appropriate for different spot. So that's the short-term goal. If it turns out that we eventually converge on one solution is appropriate for everything, that's how this will settle out.
Okay, so long as you're not anticipating, that's.
We don't know.
Okay, thanks.
We have quite a list in the. Guyan actually added a question and then Vim. So guys, promptness, shortness in the question would be helpful.
I just had a quick question. I was wondering, I guess with the interoperability, would that be something that would be added to the existing drafts, I guess, and made part of the spec, or would would there be like a third draft, I guess, that would talk to interoperability?
Guyan, I would love to. We'll have to see.
Right.
I don't normally like to come to this position, but I need to see from customers and I need to see from deployments. We'll see.
And
Wish
I-
I had a better answer.
Right. And I guess it's possible that I think as you go through the experimental, as both solutions are quite different, that you know, even though we want, but if the interoperability is not feasible, would they just still both be able to progress, I guess, to
Uh,
RFC?
I'll repeat the thing. We think it's functionally equivalent.
Right,
That should mean that we have it, but will we have it? Don't know.
right.
Why don't you let Vim ask this question, Guyan, and I'll be glad to take more offline. I apologize for the delay.
Wim Hendricks, Nokia. Yeah, I find the process a little bit strange, if I'm honest, because if we seek for feedback from operators who are going to deploy experimentally, which operator is going to try both? Do we have one that is going to do that? Because my fear is what will happen is operator A deploys A, and he will say, I want A. Operator B deploys B, and he will say, I want B. And we will not going to come to a conclusion on converging towards a single solution, I'm afraid.
I share your fear, and I hope to see something different, but I
Because
decided I
Is-
would personally like one solution, but
Is
I
that
didn't-
so here's my proposal. So is there no way like to basically come up with a, let's say, independent team, which basically take people from the various solutions in it and try to come to a converged solution rather than what we are doing right now? Because I feel that we are not converging. Because if you talk about interop, if you look to both of the things, although they try to achieve the same thing, they are incompatible right now. So the way to do interop is you have to deploy a gateway, it converts from A to B, and that's going to be interoperability, if I'm honest. And I fear that we'll end up, if we continue down this path, we'll end up deploying both, and we will have to proceed with both, because to be honest, if I'm an operator, I'm not, right? If I deploy A in my live network, I'm not going to change to B. I will keep A. And that's a bit the fear I have with the proposal that we have, or the consensus that we reached here today in the working group. I don't know what others think, but that's my personal view.
I personally share your fears.
Thank you.
Thank you very much to all the participants. Asian. Oh, you're presenting for each. Just go ahead. Sure. I forgot.
Yeah, no problem. Hi, my name is Gyan Mishra, and I'll be presenting on behalf of co-authors updates to VPN prefix ORF solution. Next slide. So the motivation of this presentation is to summarize updates. We've had a lot of feedback from the work group, and we believe we've resolved all the issues that have come up over the previous adoption calls, as well as feedback over the it seems like the last year or so. So here we're going to describe just all the updates. So the first one is the permit all mechanism is defined as a set sequence to the all Fs, and then set RD to 0. Trigger the VPN prefix ORF mechanism has been clarified. Operational process of the VPN ORF or receiver has been updated to now use a 3-tuple. So previously it was just an RD, and we did have a lot of feedback from the work group related to using RD for filtering and issues. So that has changed to now being a 3-tuple RD source PE and RT of the VPN route, and it's extracted from the BGP update. Source PE TLV to define the identity of the source of the VPN routes. We're set to a next hop community for option C for inter-domain scenario, and then set to source PE extended community for option B, where the next hop is changed to preserve the next hop at the inter AS boundary. And then lastly, route target TOV is defined to identify the RT of the offending VPN route so that the RT and RD can be used together to filter VPN routes where the source VRF contains multiple RTs assigned to different VRFs on the receiver. Next slide. So just a quick one on the permit all mechanism of VPN prefix. So due to the default behavior of ORF mechanism being a deny, this was something I believe that I believe Jeffrey Haas had brought up, and we've incorporated into the draft. So it's the deny, which supports a VPN prefix ORF mechanism, needs to send and permit all entry to its peers to ensure it can receive the non-offending VPN routes. So that addition has been added to the draft, and we believe all issues that have come up on the work group as well as from the last adoption call have been resolved. Next slide. Go on to the next slide after that. So now we're at the point, just comments and feedback from the work group. Any other questions or anything outstanding, we would like the work group to provide us anything outstanding feedback, and then we would like to prepare to proceed to another adoption call. Thank you.
Thank you, Guinan. Any questions? Okay, this will come back as part of the adoption list. You can find the order of adoption on the wiki. Okay, we're going to go on to our next person. John, you have your. We'll do it right.
Hello, everybody. It's nice to be on this side of the mic as an individual contributor. So this is work that's been discussed on the list a while, but we went through a quick name change and added a number of authors who provided some very useful feedback about how this thing is going to be deployed in a multi-vendor way in people's networks. Next slide, please. So just quick background. In the beginning in the beginning, we didn't have a good way of signaling entropy in networks, and that wasn't good for reasons having to do with it's important to be able to make use of all the links in your networks. And it's become increasingly important to be able to make use of all those parallel links. We have RFC 6790 that tells us how to do it. It's very nice. It specifies, in order to do this properly, we need to be able to signal from egress to an ingress and say, hello, I can actually parse and use your entropy labels. Now, 6790 told us how to signal that in a bunch of different protocols. One of them was BGP. Picked a very simple solution, which is just here I've got an attribute. It's called entropy label capability, but it's not a BGP capability. It's an attribute. And it's just this little dataless attribute. The type code is all that's there, really. It tells you, hey, I know how to do entropy labels. That was great. There was only one little problem with it. The RFC tells us, for heaven's sakes, don't leak this thing outside of your domain. By the way, it's optional transitive. Next slide, please. So, yeah, we actually, did we? No, never mind. So we developed sorry, somehow I've rearranged my slides. Yeah, anyhow, the leaking the attribute thing was something we needed a solution to. We developed a solution to this thing and kind of forgot to tell the world about it and kind of reused attribute 28, and we feel very bad about this. It wasn't on purpose. We're sorry. So the current draft is basically the same thing that's already deployed in Junos, but we have sort of been beaten into admitting that, yes, we really should request a fresh code point for this. The beatings were not very difficult. I mean, it was pretty obviously the right thing. So, and, you know, obviously that addresses then concerns about sharing the code point. Next slide, please. Nope, not that one. But if you haven't signed in, scan that QR code. I'll just tell a few jokes while okay, here we go. Yeah, so, no, this slide is fine. I had a funny little build, but you can just go ahead and go to the last one. So, right, just to you know, give a quick outline of the solution. As you recall, I said the previous version was a dataless attribute, and we, you know, talked amongst ourselves about, well, what are the constraints we need to fulfill here? One of them is the thing shouldn't leak, and the other is that it shouldn't require a forklift of your route reflector infrastructure in order to deploy it, and that, you know, the bottom one comes from the laws of physics, and the top one, or sort of, and the top one comes from strong input from network operators that have constraints in how they deploy code in their networks. So being able to deploy across older route reflector installations implies you need optional transitive. Not leaking implies not having optional transitive. Oh my goodness, what shall we do next, please? So next, please. Let's try again. Instead of not leaking, next, please. We said, well, what if instead of that, we do no harm if it does leak? Next, please. So doing no harm ended up looking like, well, what if we take the next hop and just copy it into data that is in this attribute, and then say, right, if I'm a receiver and I get this thing, I take a look at the next hop, I take a look at the data in the attribute, are they the same? Okay, that means that nobody has molested this thing as it comes towards me. I can be fairly sure that the router that sent me this attribute really can handle entropy labels as it promises to. If they don't match, you take the thing and you throw it out. Next, please. It's probably faster to read the draft than to listen to me talking about it. It's a very short draft. So we had some good discussion about this on the list. As I said, we, you know, in part were jawboned into moving to a new code point. Bruno suggested allowing trailing data just in case we want to do something else with this in the future. Seems reasonable. And we've also been asked, you know, you really should put in some considerations for how this thing interoperates with the thing that you already have in the field. And I think it makes sense to put in a section about that too. So very soon we'll publish a version 01 that has at least those two things. And, you know, if anybody is looking for something else, you know, please speak up either at the mic or on the list. Next, please. Right, so what's next? In no particular order, we will publish a version 1. We'd also like to have this adopted by the working group. There's, you know, a fairly obvious need to have a standardized solution here. And we've got some deployment experience that says this thing works in the field. And we'd like to, you know, come clean, get it standardized, get it out there and get it done. So my hope would be to adopt it and then fairly quickly move to working group last call. And looks like we have 38 seconds for questions. Any questions?
Swadesh, you have the mic.
Swadesh, are you muted? Oh, no, your mic isn't even turned on yet.
Hear me now?
I
Yes.
can hear you.
Yeah, hi, John. So I have a question. So now, since you are adding a little information, which is originator in this attribute, as what you just mentioned, won't it be a security concern that you are taking a transport information which may get leaked outside because this change?
Oh, that is a very interesting point, and we'll put that in the security considerations in the next version, and also give it a bit of a think to see if we can do any better. But it at least belongs in the security considerations. Thank you for pointing it out.
Greedy?
I want to apologize profusely for starting this whole thing. And thank you to John and others for fixing up my mess.
Oh, it was our mess, but anyway, thanks.
Okay, thanks, John. Next presentation is BGBSR policy extensions. Actually, no, sorry, that one's G. That one's deferred to Len. The next one is BHBLS extensions for SR network resource. Ron Chen. Is this the correct slide deck?
Live from IETF. Today, I'd like to do the presentation about BGPLS assistance for SR network resource partition sets on behalf of all authors. Next, please. Yeah, this page is the introductions, framework and definitions of IETF. Network slice is provided in draft IETF's network slice. It also defines the term network resource partition, which is a connection of resources identified in the underlay network. The solution to realize a network slicing IP-MPLS networks is described in draft IETF's NS IP-MPLS. And the IDP extension for SR network resource partition sets is defined in draft passed by LSR Spring NRP. BGP-LIS defines the link state NLI that can be a node NLI, a link NLI, or a prefix NLI. The link state information is mapped to BGP link state NLI within the BGP-LIS attribute. And this document specifies extensions to the BGP-LIS in order to advertise the information of network resource partition sets. Next, please. This is the summary extensions here. For SRPRs, we define NRPID TLV to indicate the list of NRPs that a node belongs to, and NRPID list sub-TLV to indicate the list of NRPs that a link belongs to, and the NRPID for L2 bundles to advertise the NRPID for L2 bundles member associated with a parent L3 adjacency. And also define the NRP adjacency, NRP line adjacency, and the NRP prefix set. For SRv6, we advertises advertising locators and SRv6 sets that are associated with NRPID and defines NRP SRv6 and X sets and ARP SRv6 and X sets. Next, please. Next page is the details for the extensions of NRPID TLV. The NRP TLV is used in order to advertise which network results network results that a node belongs to. And this is the format of the NRPID TLV. It mainly contains NRPID, which is used to indicate the results on specific node that will be traversed by a slice aggregate. Next, please. And this is for NRPID list sub-TLV. The NRP the RPID list TLV is associated with the link NRI. And this is the format of the RPID list TLV. It mainly contains an RPID which is used to indicate the results of specific link that will be traversed by a slice aggregate. Next, please. Next is for RPID for L2 bundles members. This TLV is used to advertise RPID for L2 bundles member associated with a parent L3 adjacency, which is point to point. And in this sub-TLV, it mainly contains L2 bundles member in RPID. There must be one RPID for each of the L2 bundles member advertised and the L2 bundles member attribute descriptor. Next, please. This is the NRP seed. NRP prefix seed TLV should only be added to the BGPRS attribute associated with the prefix LI. This TLV is used to advertise the multiple NRP prefix seeds. And the NRP prefix seed sub TLV, this is the format of the NRP prefix seed sub TLV. And it contains the NRP ID, which is identifies the NRP information corresponding to the prefix seed. And the next is NRP adjacency seed. This adjacency TLV is used to advertise multiple NRP adjacency to the controller. Adjacency seed needs to be allocated for NRP ID, and it also in this sub-TLV it also contains the NRP ID, which is identifies the NRP ID information corresponding to the adjacency seed. Next, please. This is an RP line adjacency seed. In line subnetwork, RC8667 defines the line adjacency seed sub-TLV for a router to advertise the adjacency seed of each of its neighbors. NRP line adjacency seed is used to advertisement multiple NRP line adjacency seed. And in this adjacency is line adjacency seed sorry adjacency need to be allocated for NRPID, and in this TLV it contains an RPID which is identifies the RP information corresponding to the line adjacency seed. Next, please. This is IRP seed for SRv6. SRv6 attributes with IPv6 prefix are advertised using the new BGPRS attribute TLV and associated with BGPRS prefix NRI. The SRv6 locator TLV was introduced in draft IDR BGPRS SRv6 extensions to advertise SRv6 locators and additional attributes for the given SRv6 locator. A new SRv6 NRPC sub-TLV and the SRv6 locator TLV is defined to advertise the locator that is associated with a specific NRP ID. And this subTLV is an optional subTLV of SRv6 and exit TLV, and line is exit TLV. Next, please. Comments. Next is the last page. Welcome comments and welcome to fulfill this work together. Thank you.
Ketan, you can have a very short response.
Yeah, a quick comment. All of this information is derived from an underlying LSR working group draft, which is an individual draft. My question is, why do we need a separate BGPLS draft, and why all of this can't be put in the LSR draft and handled in the LSR working group?
So we can discuss it, but I think it is better to separate. It is better to have separate draft to
Why is
discuss
that?
this.
Why so?
Maybe we can discuss. Maybe we can discuss offline. Okay.
I'll leave it to the chairs.
Okay, I'm sorry, we're gonna have to cut the mic queue due to other time. I'm having difficulty looking for the presentation for redundancy policy, so we're gonna be moving into the IGP DetNet extensions and look for the presentation.
Okay, thank you.
Shu Song?
Hi.
We can hear you.
Oh, thank you. Hi, this is Xu Song, and I will introduce our work about BGP-LS advertisement for enhanced DetNet. Next slide, please. This page just shows a very brief introduction to the work in DetNet. The most important features introduced by DetNet queues is bounded latency and bounded jitter. Also, zero packet loss and upper bound on out-of-order packet delivery. To achieve these DetNet queues features, there are 3 key technologies to implement DetNet. Including resource allocation, service protection, and explicit routines. This document is trying to give some introduction to our work about how to extend BGP-LS to support DetNet resource allocation and set up explicit routines that can satisfy the requirement of DetNet. Next slide, please. Basically, we introduce new link attribute and node attribute TLVs for DetNet bounded latency, including maximum DetNet reservable bandwidth sub-TLV, DetNet available bandwidth sub-TLV, and DetNet time resource sub-TLV. For node attribute TLVs, we introduce DetNet processing delay sub-TLV. Next slide, please. Actually, this is very similar to the BGP-LS extension for IGP traffic engineering. Because DetNet bandwidth allocated in each link could be different from non-DetNet flows, so we defined 2 separated attributes for DetNet. One is maximum DetNet reservable bandwidth sub-TLV, which specify the maximum amount of bandwidth that could be reserved for DetNet on this link. And this value should be smaller than the value of maximum reservable link bandwidth defined in RFC 5305. And also there another attribute is DetNet available bandwidth sub-TLV, which defines the available bandwidth that can be reserved for DetNet flow on this link for now, which is the value minus the the DANet bandwidth that have already been allocated for the existing DANet streams. Next slide, please. This slide shows the link attribute TLVs we try to introduce for enhanced DATnet. The key point here is that for DATnet flows, the bandwidth is not enough for describe the resource information because DATnet requires the bounded latency. So we introduce a new attribute called time resource sub-TLV. When the underlying technology is a logical queue-based scheduling mechanism, it represents a QID. And there are different technologies for implementing logical queues, for example, the existing queues, mechanisms, or FlexE or other implementation. And when the underlying technology is time scheduling based mechanisms, it can represent a time slot that could be allocated for DNF flows in each link. For example, there are some mechanisms that have been discussed in DNet working group. They introduced the cyclic queuing mechanisms, which could be considered as a special form of the time scheduling whose time slot is with equal length. Because there are two types of underlying techniques. So we also introduced two types of time resource sub-TLV. One is time resource for logical queue sub-TLV, and another is time resource for time scheduling sub-TLV. In the time resource for logical queue sub-TLV, the basic idea here is that we have a set of queues, and each queue has a buffer size and a random volume, and these two features is to guarantee the packet going through the queue with expected maximum queuing delay and minimum queuing delay, and also the expected delay variation. So that is different from the traditional bandwidth allocation mechanisms. And another attribute is time resource for time scheduling sub-TLV, and the attribute we introduced include time slot length, time slot start time, and time slot end time, which means that we can allocate a particular time slot for the link to a particular DNet flow. Next slide, please. And also for the node attribute TLV, we also introduced a new TLV called DNet processing delay sub-TLV. In the scope of DNet, the delay of each hop is divided mainly into three parts. One is link delay, one is processing delay, and one is queuing delay. Considering that queuing delay could be guaranteed by some queuing mechanisms, and which is described with the time resource ID we have already introduced. And this part which just shows that in DNet packet processing delay begins after the packet goes into the input port and ends before the packet arrives the output buffer can expect it in a known range. So the value of this processing delay could be the new attribute for enhanced DNet. Next slide, please. Next slide, please. Yeah, this is just what the others want to be done in the next step. We have a very similar document in our LSR working group to describe how to introduce these attributes also for IGP. So we would like to collect the comments both from IDR and LSR working group. And also we would like to seek for further cooperations with people who are interested in this work. Thank you.
We have time for a brief question if there's one. Fan, we found your slides.
Thank you. This is Fan Yang from Hawaii. And on behalf of the other co-authors, I will present this advertising the redundancy policy in BGP. Next, please. Yeah, here's some background of the redundancy protection and redundancy policy. I've already introduced in spring and PCE working group about this background, but in case there are people who are not familiar with this mechanism, I will repeat the introduction here. So redundancy protection is a generalized protection mechanism that's used in the context of the SR. And as shown in this figure that it replicates the service packet at the redundancy node and transmit the copies of the packet through multiple different destroyed paths. And the merging node transmit the first correct and eliminate the redundant packet at this node. Right now we have 4 jobs to introduce this mechanism. The first one is the first one introduced the redundancy seed and merging seed in the data plane. And the second one introduced the redundancy policy in the control plane. So the other 2 actually are the PCP and BGP extensions to support the redundancy policy. And next, please. And here's the background information about the redundancy policy. It is defined as a variant of SR policy with minimum changes. It inherits the main structure and most of the attributes from the SR policy. And next, please, I think. We have more information here. Here, that's on the left side, it is the information model of the redundancy policy. And in the redundancy policy, we introduce a new optional attribute at the candidate path level. And the new flag, we defined a new flag named redundancy flag to indicate the type of the candidate path used for the redundancy forwarding. So on the right side, it is the BGP encoding structure, and we at the same time, correspondingly, we introduce another attribute of the redundancy flag, and for the redundancy policy, that if this SR policy is with the redundancy flag, so all the seed list in this candidate path are used for the redundancy forwarding. It means that each seed list will carries the entire copy of the service packets. So so in this case, that there is no weight, so there's no load balancing function. It means that the weight of each seed list is not applicable. So on the right side, so there is no weight attribute for each segment list. Next, please. So here we defined a new flag sub TLV for this at the candidate path level, and this new flag sub TLV is optional TLV, and it distributes the flag of the candidate path. Currently, we used 8-bit to conveying the flag information, but at this writing time, that we only there's only one flag redundancy is defined. And next, please. As defined or as described in the redundancy policy, in the draft of the redundancy policy, this redundancy policy is optionally associated with a bounding segment, and this bounding segment can only be the redundancy segment, and all this background information is described in the previous draft. Describe the redundancy protection and the redundancy policy. When the redundancy policy is associated with the bounding segment, the redundancy segment, and so the bounding seed or the SR6 bounding seed and the endpoint behavior of this bounding seed, the information the information should be distributed at the same time. Next, please. And here is the entire protocol extensions to support the redundancy protection mechanism. And next, please. So next step for this draft, we would like to have more discussion on the mailing list, and for the basic that we need to keep aligned with the progress in spring, the progress of the redundancy policy. And thank you for listening, and we would like to have more to hear comments and suggestions. Thank you.
Any questions? Okay, thank you, Fan.
Hello, everyone.
We can hear you.
This is Stanley from Huawei. We did a BGP SR policy extension for enhanced DataNet. Next slide, please. Segment routing is described in draft IETF 3 segment routing policy. This draft defines that SR policy is a set of connected paths which consists of one or more segment lists. It provides a method for the head end node to instruct the source routing. RFC 8655 provides the overall architecture for deterministic networking, which provides the capability to carry specific unicast or multicast data flows with extremely low data loss rates and bounded end-to-end latency with the network domain. Draft YGG DataNet enhanced the DataNet plan enhanced the DataNet data plan by introducing bounded latency information, which facilitates the DataNet transmit node to guarantee the bounded latency transmission in data plan. Based on that, draft Spring SR enhanced DataNet defines how to leverage segment routing and segment routing over IPv6 to implement bounded latency. This document defines the SR policy extensions to carry the bounded latency information with a connected path of SR policy, so that BLX behavior can be enabled automatically when SR policy is applied. Next slide, please. These are the overview of the related drafts. We have two enhanced DataNet draft for the data plan and 4 drafts for the control plan. Next slide, please. Bounded latency information is used to indicate the requirement and resource allocation for each of the node in the path to guarantee the bounded latency transmission. When using SR policy to deliver the connected DataNet path, the BLI need to be encapsulated in the SR policy, and then the head node pulls it and writes it into a package. The format of BR is as the figure button right below. It is proposed in draft YJJ DataNet enhanced data plan. Next slide, please. We need different kinds of BR to guarantee the bounded latency transmission. When all of the nodes are addresses in the explicit paths indicated by the segment list requires a different BRI. We define the BRI list sub-TRV to provide the bounded latency information for each node or addresses in the path. While when all the nodes or addresses in the explicit path indicated by the segment list requires the same BRI, we define the shared BRI sum PRV to provide the bounded latency for all the nodes. Because each segment list represents a path, and the bounded latency is also associated with a path, so the bounded latency information needs to be encapsulated in the segment list. Next slide, please. This is the procedures that how the originating nodes and the receiving node deal with the bounded latency. The originating node of SR policy must include the associated bounded latency information in the GPT internal encapsulation attribute of the BGP SR policy for the bounded latency connected parts. When a BGP speaker receives a SR and the bounded latency path is selected as the best connected path, the receiver node of SR policy must encapsulate the specific bounded latency information to the header of packets and steer to the SR policy. Next slide, please. Well, the next steps, we are welcome any discussion on the main list, and the content of this draft also need to keep along with the progress in DataNet. Thank you.
Any questions? Thank you for your presentation. Next one will be Shun Wan.
Hello.
We can hear you.
Okay. Hi, everyone. I'm Sun Wang from Huawei. The topic I'm presenting is how to use a new BGP extended community to identify the target node. Yes. This work has been presented at IETF 101 and 109 meetings, and we get a few good feedback from the IETF community. Thanks to everyone for their useful comments and suggestions. At this point, all the comments have been addressed. Here is updates since the last presentation. We add some text to enable RR to configure local policy to reflect the updates to the match the BGP peers. And we add the text to on security consideration. Thanks to John for the useful comment. Next, please. Here we give a detailed example to describe why node use RT to identify the target node. RT is designed to control the export and import of the VPN routes. An RT can be shared by multiple nodes. In our example, node A advised a VPN flows back the route with 2 RTs. RT node B and RT read. The node B RT is used to identify the node B, and the read RT is used to export the root to the VRF read. RR reflect such routes to the node D. The node D receive such routes, then export it into VRF read. In this case, using RT cannot prevent the node D from importing routes that do not belong to it. Therefore, we need a node target community that is different from the RT. Next. Oh, this draft introduces a new BGP external community is used to carry the target node information. The subtype value for the extended community has been assigned, and this feature has been included in our product roadmap. Next, please. All the known comments have been addressed. Now we request WG adopt this work. Any more questions or comments are welcomed. That's all. Thank you.
Do we have any questions? It appears not. Thank you for your presentation.
Okay, thank you.
G, if you're speaking, we cannot currently hear you. Okay, G, still not heard in the room.
Me?
We can now hear you.
Really? Okay, so now it's good.
It's good.
Okay. Thanks for arranging these topics. But I cannot see the slides now. Are you sharing the slides, or it's only me cannot see it?
It is only you. We're sharing the slide.
Okay, maybe I can.
If you could pull up your local copy of the
on my-
slides, I'll just talk you through the slide numbers.
Okay. Yeah, now I can see it. So I can see the background page.
Currently are displaying slide
So,
2.
Okay. So for the background, we know the segment policy defines a set of candidate paths, and each of which consisting of one or more segment lists and associated information. And it can be used to steer the packet to the asset policy and augment the packet header with a segment list. For the network slicing, the concept of network resource partition was defined as a collection of the network resources allocated in the underlying network. And so the IETF network slice services can be mapped to the NRP to obtain the required service performance. For a network which consists of multiple NRPs, as a policy may be associated with a particular NRP, and this association between the ASA policy and the NRP needs to be specified, so that packets steered to the ASA policy can be augmented with both the segment list and the NRP identifier. This document defines the extensions to BGP as a policy, so that we can indicate the NRP which the as a policy is associated with. Okay, next page, please. It's a bit slow.
We are on slide 3.
Okay, let me open it on my side. Still cannot see it. That's okay. So
the slide is labeled BGP
so
SR
for the SR policy
extensions for NRP.
extension, okay, for the SR policy extensions, we define a new subtier we call the NRP subtier in the BGP tunnel caps attribute. It can be carried in this BGP tunneling cap attribute when the tunnel type is set as a policy. And this the format is shown in this figure, and we have the flex field. None of the flex is defined as for now, and the reserve field is also reserved for future use. And the 4-octet NRP ID, which is to identify the domain-specific significant identifier of the NRP. And the value 0 and the FFFF are reserved. Okay, next page, please.
We're on slide 4.
Okay, so here is the updated BGP as a policy encoding. We can see here we add the NRP TLV as a attribute of the candidate path, so that it is shown in this encoding structure. We think that is so that we can identify the NRP ID associated with a specific SR policy candidate path with this mechanism. Okay, next page.
Slide 5.
Okay, so for the procedures, basically the originating node of the data policy should include this NRP sub-TLV in the BGP tunneling caps attribute of the data policy to specify the associated NRP. And the setting of other fields are not changed. So when the SR policy ingress node receives this SR policy candidate path, which is both acceptable and usable, it should encapsulate NRP ID into the header of the packets which are steered to the SR policy. And here we add two references to the draft which define the encapsulation of the NRP ID in the both in the IPv6 data plane and the SR MPLS data plane. Okay, next page, please.
Slide 6.
Here we add some operational considerations. Although we think this proposed mechanism allows to associate the different candidate paths in one as a policy with different NRPs. But in normal scenarios, it is considered that the association between the as a policy and the NRP is consistent. So that we think in normal case, all the candidate paths of the same as a policy should be associated with the same NRP. Okay, next page.
Slide 7.
So for the next steps, I think this mechanism is straightforward and the document is short. I would like to suggest people to give it a read and send comments and feedbacks to us or to list. And we would also think this draft has been stable. So maybe we consider the working group adoption. Okay, thank you.
Okay, we have time for questions. Are there any questions? We have no questions.
Thank you.
Thank you, Xi. Okay. So this comes to the end of the materials for IDR. We see there's some interesting and energetic discussion happening in the chat. Feel free to take any of that to the mailing list. Aside from that, this ends IDR for IETF 114. We will see you in London. Thank you.
Do you think there's any push these guys for this? Their use case. Yeah, let's see. I would take a look at it. So you could use it.